Hello there, everybody. Me here, your everyday science and actually study buddy. I think I'll just have to call myself that. Not really proud of the name, but anyways, well, I'm here to actually explain to you and teach you some stuff. That stuff being like IGCSE, maybe physics, chemistry, biology, some of the subjects. These are just the beginning. So, well, as today I'm gonna be first of all covering physics and measurements. Not your measurements, but physics measurements. Yes. Now, as you guys might all know that there's a pandemic going on outside and like there's lockdown everywhere and like I think almost the whole world is now basically studying online and as most of you out there already know, online is a big trouble, big no-no. Like it's hard to understand stuff. So well, and actually November, December, September, October, November. Yeah, that's it. I'm even forgetting months. Jesus. Now, those these 2 months have the thingy, have an exam coming up. So, well, this is to basically revise for that and help you understand all the topics that you might have not understood before. Yeah. So that's all for the intro. Now let's get into the topic itself. The first topic is measurements. I'm going to go a bit slow, by the way. So there's units and basic quantities. Now everything has to be measured, yeah, for it to be actually useful. So the size of the quantity has to be measured and an instrument is used for that. Now there's three basic quantities we measure in physics. There's length, there's mass, and there's time. Well, so these are the three main units, and the other units are basically like these ones are used for those units. Like distance, let's say, you can use length and time for the distance. Why not, right? Like the length of the road is basically the distance, I guess. Sure. I mean, let me be honest. I might be teaching you, but yes, I'm actually also learning myself because that's how I learn. Now, there's three things here. Mass. Mass is the amount of matter in an object. So like, you know, like maybe the computer, the device, the screen in front of you that you're holding or you might be watching on, is made of matter, and matter is basically atoms. So that's the mass. What you're holding is basically mass. Now there's volume. Volume is the amount of space occupied by a three-dimensional object. Yeah. Now what this means is, let's say water. Water is 3D. I definitely can see it every day in 3D. Now, how much space is required in a bottle to hold a certain amount of water is basically the volume. Like let's say the volume of, I don't know what, mineral water bottle is 2000 cubic meters. We'll get into that later. And time is basically the progression of events. If you don't know time, what are you doing, man? Go to nursery. I don't know. Now the units of other quantities are based on them. Yeah, that's what. Now the S1 unit. Now there is a decimal system of division and multiplication by 10, which is basically to simplify numbers. You get? Now let's say, too far. There we go. Now let's say 4000. Now 4000 has how many zeros? 1 0, 2 0, 3 zeros, and basically, which means 1000. Basically, it means 4 times 1000. 4 times 1000. Now, sorry for my handwriting, by the way. I'm using a mouse, so yeah. Now 4000 times 1000, and 1000 is made of 3 tens. You can basically that's simple math. You can each 10, like 1, 2, 3, basically is equivalent to the number of zeros. If there's 2 zeros, there's 2 tens. There's 2 zeros, there's 2 tens. There's 1 0. Jesus. Yeah, there's 1 0. There's 1 10. There is no 0. there is no 10. Ta-da! Easy as that. And if there's like a 0.4, you basically divide it by 10. I don't know. Yeah. Now you basically count the amount of tens, the number of tens there is. So here is 1, 2, 3. So it's basically 4 times 10 to the power of 3. Like here, it's shown here. This one. Yeah. Was 1, 2, 3, 3. Now here's 4 to the power 10 of 0 because there's no tens. So it's 0. There's literally, that's how many times the number is occurring. My bad. Yeah. Now this can get a bit tricky, but like it's actually very simple. Since it's 0.4, it's basically 4 out of 10. Now this is basically the reverse, which means there is a negative 10 here. Like instead of having a 10, there is a debt of 10, which means there is a 10 to the power of negative 1. I don't know if that makes sense. But like if it's division, like if it's 4 divided by 10,000, it's basically 4 to the power of 10 to the power of negative 4. There we go. Now these are called powers of 10 to be exact. 4 to the power of negative 4 times 10 to the power of negative 1. Yeah, that. Now this way of writing numbers is called standard notation. It's right here, standard notation. Yep. Now there's length. Now length might be pretty easy. You use length in our everyday lives, like an inch, in suggesting height, in suggesting how long, like how far you're away from some place. I don't know. So you use kilometers. There's nanometers. That's a bit more physics related. I don't think you use this in your everyday life because, well, whew, yeah. So length is the distance traveled by light in a vacuum. Okay, that's interesting. So here's the things. Equivalence, like I don't know how much a decimeter is equal to. M is meters, by the way, and well, decimeters, centimeters, millimeters. This looks like a utorrent sign, but it's actually micrometers. Don't get confused. Don't just write utorrent meter. That's not how it works. I know my jokes are bad. But guys, I'm trying, okay? I'm trying. It's better than one for teacher, okay? Now, if you're let's say you're using a ruler, yeah, to measure how long something is. Let's say a rectangle on your piece of paper, how long it is. If you have to see the ruler from on a 90-degree angle, because if you see it from here, you see there's a difference. Like the object is here, and that space between the ruler actually, messes up with how you see it. Because well, it's light. It's all because of light. We'll probably get to that someday. Not today though. So you have to always look at the ruler from a 90-degree angle to get the exact correct point, if you know what I mean. Now there's significant figures. Yeah, well, significant figures, there's that. It's every measure of a quantity. It's basically how you write numbers. Now significant figures is basically like this. It's how many numbers there are. You see, now there's one number, two number. So there's two numbers. That means there's two significant figures here. Now this, you might say, this is how many? 5 significant figures. 1, 2, 3, 4, 5. But no, there's more. Because 0 doesn't have a value. So you don't count it as a number. Just erase it. It doesn't exist. So you see there is 1, 2, 3. 3 significant figures right here. And that's how it works. Oops, wrong thing. Yeah, so the 5 the least, blah 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 blah. There's more blabbering going on in this textbook, but no need for that, because I'm here to simplify your things. And if you don't, just watch, roll back and just watch. I'm sorry if I'm too fast. And please guys, just like and comment and subscribe, and comment below. Yeah, I don't really care about criticism. Just tell me what is wrong with my stuff so I can improve later on and just eventually provide better content for you guys. Yeah. Now that's all about significant figures, I guess, that you have to know. Now there's area. Area is basically the, I don't know, how much is covered by something, I don't know. Oh boy, I went too far. Three, two. Yeah, so area is basically like let's say the square, yeah? This square. The area of it is 3 by 4 or 4 by 3, I don't know. But area equals to length times breadth, or you can also just say width. So length is this, I'm guessing, and this is the breadth. So that's basically what area is. It's pretty simple. Just take the centimeter around the, it's the distance covered by, I don't know, man. I don't know what the area is. I don't know how to explain it. I'm dumb. Okay, so yeah, you can see here the square is basically 1 centimeter by 1 centimeter. Now how many squares? 1, 2, 3, 4. That's 4 centimeters. Yeah, it's right here. And this is 3 centimeters. Now 4 times 3 is basically 4, 8, 12. The answer to the area of this rectangle is 12 centimeters squared. Hey, it's right here. And keep in mind, you say centimeters or whatever the area is. If it says 3 kilometers by 4 kilometers, answer would be 12 kilometers squared. Don't forget, please don't forget this 2 here. It's very important because it will actually, that, yes. Just don't mind the S. Just know that the 2 exists. Don't forget that 2, because examiners will mark you wrong. Yeah, now I sound like my teacher. Great. No offense, teachers, if you're watching. Sometimes we need to know the area of a triangle as well. Now the area of a triangle is actually also easy. Its base, the base being this, the, you know, what the triangle is standing on, the support of the triangle. Then there's the height, which is, don't mind that line, the height, which is like this, you know, this straight line here, how tall it is basically, because you can't just say how this is its height, because, well, it's not. The straight is the height, because if you're slanting, you're not tall, but if you stand straight, you're tall. I'm saying this because I'm short. Yes, that just got emotional. Anyways, so the area of the triangle is basically half times base times height. The half being because base is like basically like the length and height is basically the width, but the half is there for a reason, because it's basically like a square. If you do this, like if it's 2 triangles, it's a square. Yes. Now if you cut the square in half, it becomes a triangle. So that's why the half exists. Guys, if you're to pass in your exams, don't cram. You have to understand. And that's how I understand. You know, by applying the knowledge practically, even the simple stuff. That's the key. Now if you have such a triangle, you're telling me, how will you find the height? Because both these parts are slanting. Well, no worries, because they will definitely give you this dotted line here, which is basically like the tallest point from a 90-degree angle, and they also gave it here, which is 4 centimeters, and the base is 5 centimeters. Now you don't just cut it in. You don't be like, okay, since I'm gonna be taking this triangle, I'll just cut it in half and measure from here. No, don't do that. You're measuring the whole thing. Okay, you're measuring the whole thing. So now the answer here would be a half. Why am I even writing it down? It's right here. A half times base, which is 5, times the height, which is 4 centimeters. The answer would be 10 centimeters. 10 centimeters, because 5 times 4 is 20. 20 divided by 2 is 10. There we go. Simple as that. Now, what's next? Bring it on. Bring it on. Eh? Volume. Now if you have learnt area, volume is pretty easy, because area is basically one for two-dimensional figures like squares and all that. You know, like a plot of land basically, which is basically a rectangle, cause, well, it's a rectangle because it's laid down. You get? But then you have volume. It could be like a box right in front of you. Maybe like that cereal box you have been eating every morning, and now I'm hungry. Great. But anyways, volume is the amount of space occupied by an object. Yeah. See, the unit of volume is cubic meters, which is m3. And cubed is different. Wait, no, squared is different from cubed. Yeah. Squared is 2, cubed is 3. Just don't mind my handwriting, please. You know what I mean. Now, the unit of volume is that. Now let's scroll down below. Now this is the formula for volume. Volume equals to length times breadth times height. Now you got the. Now height is actually very important here, because, well, okay, now there's 3 for a reason. Yeah, usually it would just be length times breadth, which is this. Length is this, or I don't know, this, I don't know, whatever you want to call it, and breadth is the other one. But since it's a 3-dimensional figure, this becomes height, like how tall this thing is, and this is how long it is. Wait, no, this is how long it is, and this is how, wait, no, this is how broad it is. Yes, thick with 2 C's. Yes. Now, and this is how long it is, so it becomes length times breadth times height. There, done. Easy. Moving on. What's next? Meniscus. Volume of a sphere of a radius r is, okay, let me just get this straight. Yeah, you have a sphere, which is basically a circle but in 3-dimensional figure, like a Pokemon ball. You want to know what its volume is, how much Pokemon it can hold? You use this. Now let's say the radius of a Pokemon ball is I don't know, 5 centimeters. The formula would be 4 over 3 pi, not like apple pie or something. This is math pi, pretty boring, I know, times 5, which is the radius, cubed. Now if you calculate that in your calculator or whatever, you'll get the answer. And a cylinder, this is where it gets a bit tricky. It's the same as a sphere, but not. Haha! It's not at all, because this is what makes a sphere, and what makes a cylinder is, well, okay, you know the area of a circle, of course. It's pi r squared. Now you just add an edge to it. You just add the height, because, well, let's see here. As you can see, the area of the circle still remains the same. It's the area, yes, it's done. But now you're seeing how high it is. This will get the actual volume of how much water there it can hold. I don't know if I'm making sense, but I hope I am. And yeah, these things are still the, like, the centimeters cubed and all that are still the actual measurements. Now this is the meniscus. You can go and try it like in a cup or glass right now. You might be thirsty. I know I am. Now this is actually the meniscus. The water actually goes like this. I think this is due to gravity, but yes, it is like that. Now the way I see it is this way, like this is what is going to your eyes, but you cannot actually see the gap there is, if you know what I mean. Let me just erase it, and you can actually see the actual figure. You see, like it curves down a bit. I think that's due to gravity though. Even here there's a meniscus. That's what you call a meniscus. That's right. Jesus, can I just not do something correctly? Here's what you call a meniscus. There. That's a spelling. Yeah. And this is a burette, by the way. It's an instrument, like a tool. Yeah. Now we are moving on to mass. The mass of an object is the measure of amount of matter in it, and kilograms and grams and all that. That is mass, not weight. People usually get these things totally confused up. Mass is different from weight. They even have different spellings. For God's sake, they even have different starting letters and different number of letters in it. Okay, but coming to the physics way, mass is the amount of object, like a matter in an object, while weight is basically like a force due to gravity acting on an object. I don't know if I said that right, but I hope it does. But just know the measurement of mass is kilograms or grams or whatever. Yeah, it's right here, grams, G's, whatever. The term weight is often used when mass is really meant. In science, the two ideas are distinct and have different units. Okay, so what this means here is actually that the mass of an object is measured by weighing. We call it weighing, not weight. You basically weigh mass, not weigh weight. It's pretty confusing, but you will get used to it. So now it's all measured in a balance. Yeah, it's all measured in balance. There's several types of balances actually. There's a beam balance. So you basically have like a seesaw kind of thing, and then you maybe put like something, a known mass, like maybe put 5 kg here, and you put like some other mass you don't know, maybe bag of rice, to measure how much like if they both balance together, well, the rice is 5 kgs, the bag of rice is 5 kgs, easy. Then there's a lever, in which a lot of levers basically work. I don't know how to explain that. Now moving on, there is also pan. What? Oh, a direct reading. Oh, here's a top pan balance here. So you basically this is used a lot in the modern days, so I guess you know that. Now there's time. The unit of time is a second, which is used to be based on the length of a day. So it's basically seconds, minutes. You know what time is. It basically is because the earth is revolving. It's revolving around, like it's rotating. Yeah, so each part of the earth is facing the sun different times. And that, I think time is pretty easy. So yeah guys, I'm actually running a bit late, so see you next time. Thanks for watching.